Okay, in this problem, we're asked to evaluate the difference quotient of the function f of x equals x cubed. So this formula right here, this is called the difference quotient. And what this gives you is the slope of the secant line. So this gives you the slope of any secant line between two x values that are a distance apart of delta x. Okay, so to evaluate this difference quotient, we have three parts. We have the f of x plus delta x. We have the f of x, which is x cubed, and we have the delta x. So let's start off with the f of x plus delta x. Okay, so that basically means we take x plus delta x and we substitute it into our function for x. Okay, so what does that look like? Our function is x cubed, so instead of x cubed we have x plus delta x cubed. All right, so let's expand that. We're gonna have to multiply out, so that's x plus delta x times itself 3 times x plus delta x times x plus delta x times x plus delta x. Okay, so let's FOIL this out. Let's deal with the first two. Okay, so that's say first times first, x times delta x, or sorry, x times x, so that's x squared. Then we have, let's erase this, so we have some more room here. Then we have outer times outer, inner times inner. So outer times outer is x times delta x. Okay, so that's x times delta x. Inner times inner here. We have another x times delta x. Let's use some parentheses here because delta x is one symbol. The delta and the x are not separate. Okay, and then last times last, delta x times delta x. So that's delta x times itself, or delta x squared. Okay, and we still have this last x plus delta x. Okay, so let's put that here, x plus delta x. Okay, now let's simplify. We can combine like terms. This x plus delta x and another x plus delta x. We have two of them. All right, so it looks like we have x squared plus 2 of these x times delta x's plus delta x squared. Okay, and we're multiplying by another x plus delta x. Okay, so we have to distribute, so x times each one of these terms, and then a delta x times each one of these terms. Okay, so if we multiply through the x first, x times x squared is x cubed. All right, then we'll have an x times the 2x delta x. So that will give us 2x squared times delta x. And then we'll have a plus x times delta x squared. Okay, and then we'll multiply through the delta x. So delta x times x squared. Okay, so we have a delta x times x squared. We have a delta x times 2x delta x. So we have delta x times delta x, which will be delta x squared. So that should be 2x times delta x squared. And then delta x times delta x squared. Okay, so that should be a delta x to the third power. Okay, so let's see, can we combine any like terms here? All right, it looks like we have a 1x delta x squared and a 2x delta x squared. We could definitely put those two together. Okay, so it looks like we have x to the third power plus 2x squared delta x plus 3x times delta x squared plus a x squared delta x. Oh, it looks like we could combine those two now. Yep, definitely. Plus a delta x to the third power. Okay, I could have done this in the last step, but let's do it now. We have a 2x squared delta x and a 1x squared delta x, so they could go together for sure. Okay, so we have, ooh, it should be blue. Okay, so we have x cubed plus 3x squared delta x plus 3x times delta x squared plus delta x to the third power. Okay, so this expression here is just the f of x plus delta x. All right, so now let's plug this into the formula for the difference quotient, or this expression that we're trying to evaluate, the f of x plus delta x minus f of x over delta x. Okay, so f of x plus delta x minus, so let's actually change this to blue, f of x all over delta x. Okay, so our f of x plus delta x is here. Okay, so that's x cubed plus 3x squared delta x plus 3x times delta x squared plus delta x to the third power. Okay, and now we have minus f of x. And f of x, our original function f of x, is x cubed. Okay, so we'll subtract off an x cubed. And we have all of this over delta x. Okay, so our first term is an x cubed, our last term is a minus x cubed. So we could definitely cancel those two out. Okay, so we're down to 3x squared delta x plus 3x times delta x squared plus delta x to the third power all over delta x. Let's put those in parentheses. Okay, so in the numerator, each term contains a delta x. So let's factor out a delta x. Okay, so we'll have a 3x squared. From this first term, we'll factor out the delta x plus a 3x times 1 delta x. So we have to the second power. So one of those is factored out. Plus delta x to the second power. Okay, so we factored out a delta x in the numerator. And now we could cancel that delta x on top with that delta x on the bottom. Okay, so it looks like what we're left with is 3x squared plus 3x times delta x plus delta x squared. And at this point, it looks like this is as far as we could go. So this is our simplified expression. Okay. All right, so that does it for evaluating the difference quotient for x cubed.